Hello class, and welcome to our Chapter 4 review. I tried to cut out as many problems as possible so it'd be nice and short for you, but still have enough in there for you to have enough practice. If you do find that you need a little more practice, make sure you rewatch some of the old videos or go on to the book where you can find more problems. So go ahead and try these 4 problems out. See if you can solve them as best you can. When you're finished, press play and let's go over the answers. Okay, welcome back. Let's go ahead and begin. 10 to the 4th power tells us there will be 4 zeros. Notice there's no negative sign, so that means there won't be a decimal. So you simply have a 1 with 4 zeros. 10 to the negative 7th power tells you there'll be 7 zeros, and that negative sign tells you should have a decimal in the beginning. So 1 0 in front, decimal point, 6 zeros after, and a 1 on the end. Remember, it does end with the 1. Number 3, you're doing the opposite way, turning it into a power of 10. All you have to do is count the zeros. As you can see, there are 8 zeros, 10 to the 8th. Here, when you count the zeros, you can see that there are 5 zeros. Also, you'll notice that decimal point, which tells you should have a negative sign, 10 to the negative 5th. 4.2, go ahead and do these 4. Press play when you're ready to see the answer. Okay, writing in scientific notation. Remember, that means we need to move our decimal point until there's only one digit that has value in front of the decimal. So that means the decimal point is going to end up between the 7 and the 3, which means I will have moved the decimal point 5 places. So my exponent will be 5. 7 3/10 times 10 to the 5th. Problem number 2, notice there's a decimal in front, so right away I can tell my exponent's going to be negative. The first digit that has value is the 9. So I'm going to move my decimal between the 9 and the 4. So my answer will be 9 45 times 10 to the negative first. I do need that negative 1 on there, showing that I'm moving it 1 place. Write the number in standard form. I'm going to do just the opposite of what I did above. I'm going to move the decimal point 9 places. Now, since the 9 is positive, means I need to end up with a nice large number. So I want to move my decimal point to the right. And I end up with 3,200,000,000,000. And notice I've moved that decimal 9 places to the right. Number 4, I've got a negative exponent, so that means I'm moving it to the left. I should end up with 0 point something for my answer. And I need to move it left 3 places. So 0 and 71 10,000ths. Okay. 4.3, go ahead and solve these. Press play when you're ready to see the answers. Okay, let's take a look. You're going to need a couple steps here. First and foremost, we need to get rid of that negative exponent. So I'm going to turn it into a fraction, 1 over negative 4 to the 3rd. Now, if I write it out so I can visualize this better, notice I'm multiplying the whole thing to the 3rd power. So that means 1 over negative 4 times negative 4 times negative 4, and I'll end up with negative 1 over 64. Remember, I always write the negative sign at the beginning of the fraction, because if I were to write 1 over negative 64, it's going to look like a subtraction problem. Problem number 2, I need to replace that y with a 4, and then I can again turn it into a fraction. So 1 over 2 to the 4th. Notice I took my negative sign and I brought it out to the beginning. The reason for doing that is because we don't have any parentheses. That means that the 2 is not being raised to the 4th power. Or excuse me, the negative is not being raised to the 4th power, only the 2. So I just put the negative out in front so I don't forget about it. Then I'm simply multiplying 2 times 2 times 2 times 2. And I end up with negative 1 over 16. Okay, last one on this page. Simplify the algebraic expression. I need to split these up. I've got negative 24 and m to the negative 6. I can split them up, and then I can take care of m to the negative 6. Remember, to get rid of that negative, I have to put a 1 over it. Notice I also put 24 over 1 just to help me with my fraction. And if these were written right side up, it'd make it a little easier to read. You'd see the negative 24 here is being multiplied by the 1 in the numerator here, which would be negative 24, and the 1 in the denominator is being multiplied by the 6m in the denominator, and that is your final answer. Okay, 4.4. Go ahead and try these out. Press play when you're ready to see the answer. Find the two square roots of 900. Notice it's not telling you which one it wants, which means it needs both positive and negative. So let's take a look at these answers. You should have 30 and negative 30. Find the square root of radical 225. Notice the radical sign is telling you whether it wants positive or negative. If you have a negative sign, then of course you want a negative answer. In this case, you do not, so we have a nice positive answer. Between which two consecutive integers does the square root lie? And that square root is radical 83. So I'm going to line those out. 81 is a little smaller, 100 is a little larger. I can square root both those numbers, end up with 9 and 10, and my answer would be 9 and 10. Last problem, it's asking you to take it one step farther. So instead of just stopping with a 2, you want to pick which one it's actually closest to. So we're going to do the same thing, 9 and 16, square rooting that, and I get 3 and 4. And then looking back, I can see to get from 9 to 15, I had to count up 6 spaces. To get from 15 to 16, I only had to count up 1. So obviously 15 is closer to 16, so that means my answer would be 4. 4.5, if you take a look at the top, I do have a list of perfect squares at the top of my screen. I would write those down every time on your test, on your quizzes, to help you remember those perfect squares. So go ahead, simplify these three expressions. What that means is, again, pull out the perfect squares and square root them. Leave everything else under the radical. Okay, welcome back. Let's split up radical 60 into two separate radicals. 60 is the same thing as 4 times 15. 4 is obviously a perfect square. 15 does not have any perfect squares within it, so I'm going to leave it alone. Square root of 4 is 2, radical 15. 3 times 27, I need to combine them first, and 3 times 27 is 81. And 81 is a perfect square. When I square root it, I end up with simply 9. Now, radical 43 over 400. It's a little hard to see sideways. Unfortunately, the way the computer prints it, it's a little bit hard to read. But what you want to do is square root each of them separately. Radical 43 is not a perfect square, and it doesn't have any perfect squares within it, so we leave it alone. Radical 400 would be 20. So now my radical sign is only over the 43. So be very careful there. Okay, last three. Tell whether the number is rational or irrational. Explain why. Radical 16 is rational because it's the square root of a perfect square. My answer would simply be 4. Problem 2. Radical 7, my answer is irrational because it's not a perfect square. When I square root that number, I'm going to get a decimal that is non-terminating, non-repeating, going on forever and ever. And problem number 3, my answer is rational because it is a terminating decimal. It stops at the 6. Okay, hopefully you did all right with those. Go ahead and go on to the quiz and have a great day.